when you're presented with a linear equation where you have variables on both sides, you're going to need to get all of the variables to one side using addition or subtraction. And then if there's, constants on both sides, you'll need to do the same with them, get them to the other side away from the variable, and then just divide by the coefficient on the variable. Occasionally we may have to do some combining of like terms first, but in this first example, we don't have to do that. We just have 5x equals 3x plus 10. So we have variables on both sides. So all we have to do is move the 3x from the right-hand side to the left-hand side. So we'll just subtract 3x from both sides. 5x minus 3x is 2x. 3x minus 3x right here just cancels out. We're left with 2x equals 10. Since now all of our variables are on one side and all of our constants are on the other, we just divide by the coefficient on the x, which is 2, giving us a final answer of x equals 5. Fairly straightforward. In this next example, we can see that there are constants on both sides, and there are variables on both sides. So we'll start by getting all the variables to one side. It doesn't matter which side you bring them to, you'll get the same answer in the end. Personally, I like to try and bring them to the side that's going to end up giving me a positive coefficient. So if I were to subtract 7x, I'm going to do 2 minus 7. That's going to give me a negative coefficient. So I'm not going to choose to do that, although it will work. I'm going to choose to subtract 2x from both sides. When I do that, I only subtract 2x once from each side, right? And it just gets combined, just like we're combining like terms, with the x terms. This minus 4 isn't going to be affected at all. So we'll do 7x minus 2x, which is 5x. And then we'll keep the minus 4 equals, well, 2x minus 2x cancels out, and we're just left with the 16. Now we should be able to get all of the constants moved to the other side. So we'll just add 4 to both sides, because now this is just a regular two-step linear equation. I'll put the result up here. The 5x will stay. The negative 4 plus the 4 will cancel out. Since 16 plus 4 is 20, we have 5x equals 20. And we'll just divide both sides by the 5 to get our final answer of x equals 4. For this next one, I'm going to choose to get my variable to be a positive coefficient. So I could choose to add 8x, or I could choose to, from the minus 8x, or I could choose to subtract 3x. If I subtract 3x, I'm going to end up with negative coefficients on the other side. So I'm just going to add the 8x so that I have a positive coefficient there. Now, it doesn't matter. Again, you'll get the same answer if you do it the other way. It doesn't matter at all. Just my preference is to keep it as a positive coefficient. So negative 8x plus 8x right here is going to cancel out. We'll just be left with the plus 3, or 3 on this side. 3x and 8x is 11x. And we have plus 14. Now we want to get all the constants to the other side. So we'll subtract 14 from both sides. Now this one is going to give us a negative. That'll happen sometimes, but not a huge deal. We'll go up here. 3 minus 14 is negative 11. And we have negative 11 equals 11x. So when we divide by the coefficient on the x, the 11, we just get negative 1 equals x. And that's our final answer. For this one, we can see that there are multiple variables on the left, or multiple instances of the same variable on the left, as well as that variable on the right. We have a 5x, a minus 7x, and an 8x. There's variables on both sides and 2 of them on that left side. And the same goes with the constants. There's constants on both sides, and even on the right-hand side, there's a 4 and a negative 31. So our first step here is going to be to combine like terms. But when we combine them, we're only worrying about each side separately. So on this side, I have 5x and minus 7x and a plus 3. 5x minus 7x is negative 2x. So we have negative 2x plus 3. On the other side of the equals sign, we have a 4 and a negative 31 that need to be combined, and an 8x, which is just going to stay. So 4 minus 31 ought to give us negative 27. And we still have a plus 8x. So now we've combined the like terms on each side. Now we just need to follow those previous steps that we had. Get all the variables to one side. I'm going to choose to add the 2x because I know that will give me a positive coefficient on the x on the right-hand side. And it's possible that there might not be a way to get a positive coefficient on one side or the other. So that's not necessarily going to be possible every time, but in this case it is, so we will. We're left with a 3 equals negative 27 plus 10x. And to finish it off, we just need to add the 27 to both sides, giving us 3 plus 27, or 30, equals 10x. And then divide by that coefficient of 10, giving us x equals 3. Or in this case, we've got 3 equals x, but of course they're interchangeable. 3 equals x is the same as x equals 3. So we'll do one last one where we've got this time variables on both sides again, constants on both sides, and we actually have multiple instances of the variable on both sides. So we'll be careful to combine our like terms, but when we do that, we'll make sure to do each side separate. So negative 3x plus 8x is 5x, and positive 6 minus 1 is also 5. So we have 5x plus 5 equals, and on the other side, we have 4x and minus 2x with just a singular constant of 23. 4x minus 2x is 2x, and we'll keep the plus 23 there. Now we just want to get all of our variables to one side and all of our constants to the other. So I'll subtract the 2x from both sides, giving us 3x plus 5 equals 23. Then we'll subtract 5 from both sides, giving us 3x equals 18. Then we'll divide both sides by that coefficient of 3, giving us our final answer of x is 18 over 3, which is 6. And that is how we go about solving equations, and we have variables on both sides. So combine like terms on each side separately, get all the variables to one side, get all the constants to the other, and then divide by your leading coefficient there.